Welcome back to Topic 2 for Algebra 2, Number of Solutions to Linear Equations. In this video, we're going to learn about the 3 different types of solutions when solving linear equations. So, like I just said, there are specifically 3 different types of solutions, and we're going to go through a different one in each of our 3 examples. Our first example here, we have negative the quantity 3 minus 6b divided by 2 equals 6b plus 5. Now we're dealing with a fraction here, but actually they have the same denominator. So in order to get rid of our fraction, what we're going to do is multiply our 2 on both sides, our denominator. So what we do to one side, we have to do the other. Because we have a 2 in the numerator and a 2 in the denominator, that reduces to 1. And because it's the same number on the other side, that also reduces to 1. So our problem actually is just negative 3 minus 6b equals 6b plus 5. On the left-hand side, we're going to apply the distributive property. So this is like multiplying a negative 1. Remember, 1 is a humble number. It's not always written, but it is there. So negative 1 times 3 is negative 3. Negative 1 times negative 6b is positive 6b. So we get negative 3 plus 6b equals 6b plus 5. Now, going back to Algebra 1, we want to isolate our variable, so to make sure that's on one side and our constants on the other. So I'm going to draw just a vertical line to separate my left side from my right side. I have a positive 6b on the left-hand side, so I'm going to do the inverse, which is subtraction. Subtract 6b from both sides. On the left-hand side, that adds to 0, so I'm just left with negative 3. And on the right-hand side, that also adds to 0, so I'm just left with 5. So here we have negative 3 equals 5. Now, in what world does negative 3 actually equal 5? It does not. So this is called no solution. Our next example, we have 3 plus 5n equals 5 times n plus 2 minus 7. So on the left-hand side, we are all set. But on the right-hand side, I notice that I can distribute. So I'm going to distribute this 5 to everything that's in my parentheses. So I'll get 3 plus 5n equals 5n plus 10, and then are subtracting 7 on the outside. Now I'm going to combine my like terms. I have 10 minus 7, which gives us 5n plus 3. So on the left-hand side, we have 3 plus 5n equals 5n plus 3. So you might notice now that these are exactly the same on both the left-hand side and the right-hand side. So let's bring all of our variables to one side and our constants to the other and see what we get. If we want to move our variables first, since this is positive 5n, we're going to subtract 5n on both sides. So we'll get 3 equals 5n minus 5n is 0. So 3 equals 3. Now let's bring our constants over. So we'll get 3 minus 3 is 0. 0 equals 0. Now, particularly with my students, I'm a stickler. I like to see 0 equals 0 at the end just to make sure that they have followed all of their steps and they didn't create an error earlier on. But since 0 equals 0 and our variable disappeared, we could plug in any single real number for our variable here and the equation would still stay balanced. So there are actually infinitely many solutions. To this problem. Our last example, this one looks yucky. We have 5 times the quantity m minus 1 over 2 minus 1 plus 2m all over 3 equals 5 plus n. So the first thing that I want to do is get rid of this big honkin' fraction that's on the left-hand side. So since this is all divided by 3, the inverse of division is multiplication. So I'm going to multiply the left-hand side by 3 and the right-hand side. And make sure when you multiply the right-hand side, you're not just multiplying it to the 5 or just to the m, but to both quantities. On the left-hand side, since I have a 3 in the numerator and a 3 in the denominator, that simplifies to 1, so I'm just left with this new quantity here. So 5 times m minus 1 over 2 minus 1 plus 2m, and that's going to equal 3 times 5 plus m, or 5 plus m times 3. Since multiplication is commutative, we can flip the order and we'll still get the same product in the end. Now I'm going to just quickly apply the distributive property. So I'll get 5 times m minus 1 over 2 minus 1 plus 2m equals 15 plus 3m. And I'm also going to apply the distributive property on the left-hand side now. But before I want to do that, I notice I have this fraction here, this m minus 1 divided by 2. Now, m minus 1 is in the numerator because, in other words, this is saying that they both have the same denominator of 2. So I can actually rewrite this to be 5 times m over 2 minus 1 over 2 minus 1. That's going to help isolate our variable in the end so things don't get messy. Then we're going to add 2m. And set equal to 15 plus 3m. So I can apply the distributive property, and I can also combine like terms in our parentheses first. So I'm going to combine like terms first in our parentheses. So this is going to change to 5 times m over 2. Now negative 1/2 minus 1, same sign, so we're going to add it. Gives us negative 3/2 plus 2m equals 15 plus 3m. Now I can apply the distributive property. So I will get 5m over 2 minus 15 over 2 plus 2m equals 15 plus 3m. Combining my like term, since I have 5/2 m plus 2m, remember 2m is the same thing as 4/2. So this will actually get me 9/2 m minus 15/2 equals 15 plus 3m. I'm going to rewrite this up here just for more space. So 9/2 m minus 15/2 equals 15 plus 3m. Now, all we want to do is get our variable on one side and our constants on the other. So I'm going to add 15/2 to the right-hand side. Sorry, that was the bell. And I'll get 9/2 m equals, now 15 is the same thing as 30/2, so we'll end up with actually 45/2 plus 3m. Then I can subtract my 3m on both sides. Now 3m is the same thing as 6/2, so I will end up with 3/2 m equals 45/2. So since we have 3/2 times m, and we want to isolate our m, the inverse of multiplication is division. So we would divide both sides by 3/2, but remember, when we divide by a fraction, it's the same thing as multiplying by the reciprocal. So we're going to multiply both sides by 2/3. 2 in the numerator, 2 in the denominator, reduced to 1. 3 in the numerator, 3 in the denominator, reduced to 1. We get m equals 45/2 times 2/3. 2 in the numerator, 2 in the denominator, reduced to 1. And we get 45/3, which simplifies to m equals 15. And there we go. So that was topic 2 for Algebra 2, number of solutions to linear equations. Oops, I forgot to identify this. This is called one solution. Lost my train of thought. Okay, now we're done. So that was topic 2 for Algebra 2, number of solutions to linear equations. So the 3 types of solutions are no solution, infinitely many solutions, and one solution. Thank you for watching.